Unit on electron configuration. At the end of this presentation, you should be able to explain the 3 rules of electron position, draw an off-ball diagram for calcium, copper, and magnesium ion, write the electron dot diagram, electron configuration, and noble gas shortcut for calcium, copper, and the magnesium ion. And you will need a periodic table, so run grab that. So electron configurations are just the way the electrons are arranged in the various orbitals or shells around the nuclei of atoms. And there's 3 rules. The first one is the Aufbau principle. And Aufbau is just German for building up. So the electrons want to enter the lowest energy first. And this is like the diagram here. And this is the lowest energy. And then these shells would be high energy. Pauli exclusion principle says there can only be 2 electrons in an orbital at different spins. And the way we show a pair of electrons in an orbital is by arrows. So one is up and one is down, indicating opposite spins. Hund's rule: when electrons occupy orbitals of equal energy, they don't pair up until they have to. So here's the off-ball diagram, and we're going to use all 3 rules to draw the phosphorus diagram. So phosphorus has 15 electrons. So I'm going to fill up my electrons. I'm going to use all 15. And I'm going to start here, 1s. So one's going to spin the other way. I don't have any more spaces, so then I need to fill up another one with the opposite spin. So that's 2, 3, 4, and then Hund's rule says they don't pair up until they have to. So 5, 6, 7, 8, 9, 10. Okay, so that row's full. 11, 12. Oh, my pen's messed up. 13, 14, 15. So now I'm going to stop because I've used up all my electrons. So you notice I started here, and each box represents an energy level. So 1s, 2s, 2p. I want my s to be full before my p is full. And then I can move on to 3s and 3p. And notice they don't pair up until they have to. So I didn't draw, whoops. I didn't draw this. They don't pair up until they have to. Okay, so electron configuration. This is basically writing out what we wrote here. So the electron configuration for phosphorus would be, they start in the 1s, and there's 2 inside there, 2. Then it moves to the 2s, and there's 2 inside there. 2p, and there's 6 electrons in there. 3s, there's 2 in there. Then 3p, now there's 3 in there. So this is the electron configuration. And if I were to add up all these superscripts, it would equal 15, which is the number of electrons in phosphorus. Okay, so on your periodic table, if you just by looking at the periodic table, you can figure out an element's electron configuration. So here, the number, the rows or the periods, that indicates the shell. All these elements, whoops, all these elements here, this is the s block. So their valence electrons are in the s block. All these here are the p block. All their valence electrons are in the p block. And notice that helium is still in the s block. Then we've got the d block and the f block. So when you're writing your electron configuration, this first number indicates the row that it's in or the period that it's in. The S are your subshells. You can have S, P, D, or F. And then this last little superscript tells you the number of valence electrons that you have. So this 1s1, oh, my pen's messing up again. 1s1, it's in period 1, so somewhere here. It's in the S block here, 1 valence electron here, so that's hydrogen. 1s1 is hydrogen. Now if you notice, you read the periodic table this way, left to right. So that's how you fill up your orbitals, going this way. When you get to rows 4, 5, 6, and 7, you're going to fill up 4s2, then you go down to 3d10. And then over here you pick it back up. This is 4p1, 2, 3, 4, 5, 6. So when you're doing these transition elements or the larger elements down here, make sure you read carefully. So let's do some practice, and I think it will be clearer once we start practicing. So we're going to write the electron configuration for lithium. So I'm always going to start here at hydrogen. Hydrogen is 1s1, 1s2, so my first shell is full. 1s1, 1s2, lithium's here at 2s1. If I was at beryllium, it'd be 1s1, 1s2, 2s1, 2. So iron. I'm going to start here at hydrogen. 1s1 goes to helium, 1s2, so that's filled up. Then to lithium, 1s, 1, 2, so 2s2. I'm going to continue on until I hit iron. This is 2p, 1, 2, 3, 4, 5, 6, so that's full up. Then I'm here, 3s2, keep going until I hit iron, 3p, 1, 2, 3, 4, 5, 6. Now I'm here at 4s2. Now I'm here, so this is 3d, and 3d, 1, 2, 3, 4, 5, 6. So here's iron, so 3d6. So you look at what element you're at, you want to get to, start at hydrogen, and keep reading across until you get there. So now we want to do sulfur. So we'll start at hydrogen, 1s1, 1s2. Now I'm here, 2s2. Keep reading across. 2p, 1, 2, 3, 4, 5, 6. Now I'm here, 3s2. Three p, 1, 2, 3, 4. Here's sulfur. 3p4. Alright, try calcium on your own and then check your answer. Did you get 4s2? You see where calcium is, and this is the S block, and it's in period 1, 2, 3, 4. Try krypton now. Don't forget, after 4s2, you drop back down to the third energy level. Try aluminum. You can also write a shortcut. Did you see when we went back here, do you see how I keep writing these? They're all in the same order. 1s2.